Hello, I'm Roman. Welcome back to a series of the videos of building the convolutional neural networks from scratch. And in the previous video, I kind of finished, well, at least with the initial implementation of the max pooling layer, and I continued to build the backward path for the convolution itself. And the thing is that right now, what we need to build is this part. And you can see that we actually, for the forward pass, we use only the valid version of the cross correlation, but for backward pass, we'll need to use two versions, the valid one and the full one. Full one is the one where we're using the padding around the input data. So this is how it looks. So the full one is something like this, and you can see that it reduces the size of the output. For example, I probably will have the kernel size 3 by 3, for example, and I have the output. I have the input, for example, 5 by 5, and this is the result. But with the padding is actually different. I will use the padding 1, and it changes, it adds more numbers of the element. So, and there is a formula that we can find is how in general we can compute the output size for based on the input size and the kernel. And this is what we have. In case of the full, we will have padding equal to 1, at least, well, for the version that I'm building. And it means that we can compute it as input size plus 2 minus kernel size. We are not changing the stride. Stride means that the number of the pixels we jump while we go. So for example, this is stride 1, meaning that we go one kind of shift in the region by 1 pixel. If we have the stride, for example, 3, we cannot. For example, we have stride 2. You can say that it jumps over 2 columns at the same time. But it has its pros and cons, but for simplicity, we'll go just with the straight one. So again, it means that we will have the different output size, and I need to change the way I implement the convolution. So we have so this is the cross correlation, the valid one. What I need to do, I need to change it into different one, right? And this is going to be the goal for this video for today. So again, we'll have the input as the dense that will represent the input data. We have the kernel again. And the output is the same. Right. So the first thing, I actually need to compute the number of the I need to compute the result size, which in my case will be the n is the number of, well, it's an input size, and probably I just make it input size. That's going to be kernel. So we have input size plus 2 minus kernel size plus 1, right? Same as we have here. And that means that's my output, right? And actually the main thing I'm thinking right now is how to represent the slide, because what I have right now, I have the correlate to D that takes in slice. I mean, I compute slice based on the indexes. And I mean, basically that should be the same, right? Let's go to the kernel. Right? And we're going through the output. What I'm thinking right now is that I guess I should just create the increased version of the matrix and fill it with 0 first, and then go over this one and just copy the data from the input one. So that kind of expand it in, right? And it should be input size +2 because we have paddings from the both sides. I mean, this is what I'm going to do. It doesn't mean that it always have symmetric paddings, but I will do this one. Expanded input. With 0 it. Right, and then we need to copy so we have the expanded input, we using the set, and this one is I +1, j +1, and we have the input. And that's it. And ideally, I just should replace it like this, and it should work. It should work. So what can we do? We can, as usual, create the test. We have test correlate to the full. So we have 3 by 3 and 2 by 2, which means that the output should be 4 by 4, right? And right, and the output is going to be actually bigger. Okay, so this is what I should get. So inside we will have very different results. And now how to I want to show that they will be different one. Okay, this is what should be in the result. I don't know if I can change the text size so it will be easier for you to see. So if I didn't make a mistake, then that's what it should be. Okay, so let's try. Okay. Basically, this is the same. The only thing that I don't like... Okay, let me, as usual, check that the test is valid. Okay. So we have the full cross correlation. The only thing that, of course, I don't like that it makes the second array, and I have to go one by one and actually copy the data. So it's not that efficient, and maybe I could, make a better condition here, but still, anyway, I need to create a slide that will contain the zeros somehow. So at some point I need to get the zeros. I can make some optimizations, to pass the indexes and check if it go out of bounds and use the 0 and so on and so on. But I think for the purposes of the videos that I'm doing, I think that's enough. At least for me, that's enough. So it means that I'm done with the correlate is fine. Actually, right. I want to do this. Wait, size mismatch. No. So I should get an error here. Zero length in matrix dimension. Okay, so this is the difference size of error. What if I do this? No, zero length, and interesting that I don't have it here because it should be the same. Okay, so we have the error. All right. Okay, let's take a look what will be. So this basically is done. So I will be able to use this one. So that will get me through. So I will be able to use this somewhere here. Right? Okay, but that's actually all for today. It's a very short video. I have some questions regarding this one and this one. I kind of don't fully understand how it should look like in my case. I want to compare it with revisit a little bit what I did for the dense layers. I mean, how for example, the D inputs look like. Because right now, I mean, that works for one sample again, but I will have an array of the samples. So I'm still not sure how I should convert it. And same for the inputs, it's actually computing them. So it's going to be aggregated stuff across all of the kernels, right? And I'm not sure how I'm going to use it. Well, okay, so I will actually okay, with the biases it's even weirder, especially here because they're not used. And this one, no, the filters is actually updating the parameters of the learning rate. So there is a filters in this one, but the inputs is actually not used. Also, where do I update params? Dense, for example, I'm using this one. Okay, so I have the weights update. And I do various weights. Yes, so I have the learning rate. I have it used, for example, here. Wait. But okay, so this is in the optimizer. Okay, optimizer is an interface. How many? Okay, for example, other. Oh, okay, so this is in the pre-update. Oh, we have the kernel rate, right? And yeah, so okay, so at which point I have the update params? Okay, so after I have the backward, I'm calling the pre-update. I call in the pre-update, and then I'm going over all of the layers, and if it's the 10th layer, calling the update params. Okay, this one. For example, from Adam. Okay, and this is where I actually doing a bunch of this stuff. For example, we calculate weights momentum, with cache, blah blah, and in the end I should be able to adjust this one. So for example here it's just learning rates multiplied by the T filters. I mean, which is very different from what we had in the dense layer, but I will need to understand what to do with optimizers. Because for example, can I have the different optimizers for convolutions, or it actually doesn't make sense and I can just do this right inside the backward, or need to create an optimizer for convolution as well. So I don't really know what I should do here. That's another question I need to research a little bit and understand. Maybe I will just go with things they are. So the optimizers will optimize the fully connected layers, and for the convolution, that's going to be very straightforward, like adjusting the filter, adjusting the kernel values, and that's it. And yeah, maybe that's this is how it's going to work. Okay, but for now, that's all for today. There are still a lot of things need to be done, and I still don't understand with the biases. Okay, I don't know, maybe I will skip again the recording today, as I will spend this time to actually researching what I'm missing, at least with the biases, and what to do with the inputs, at least here, because like in the current implementation where the convolution is first and only layer, I actually don't need them. And I don't need to perform actually full cross-correlation because no one is going to use those values. Let's see. Okay, but for now, thank you for watching and I see you tomorrow. Bye-bye.